Hello everyone and welcome to the Modern Software Engineering channel. Today we'll be asking the question, is 100% test coverage a pointless goal? Or to give the answer away, mostly yes, but to fully understand why, let's step back and take a look at what test coverage actually is. Automated functional tests are really useful. They help give us feedback as to whether or not our code is good enough to ship to production. If we have production code that is not executed by any of our pre-production tests, then our test suite isn't giving us any confidence around that part of the code base. Test coverage is an assessment of how many lines of your production system are actually covered by your tests. If your production code base had, say, 100,000 lines of code, but your test suite only executed 20,000 lines of that code, then your test coverage is only going to be 20%. So 80% of your code has no test coverage. So if you had a 0% test coverage, then this is likely pretty bad. You're either relying on slow and error-prone manual tests to check your code before you deploy, or perhaps you're just adopting the YOLO deploy strategy. Let's ship it and find out if it breaks when our users start using it. Now, don't get me wrong, finding problems in production isn't bad at all, but it'd be likely better to find problems before our users do. This is why we like automated functional tests. We get fast feedback about the quality of our code, and fast feedback is good. In general, the earlier you find a problem in your code, the cheaper and the faster it is to fix it. So if these types of tests are good and zero test coverage is bad, then why shouldn't we aim for 100% test coverage? Well, there are a bunch of issues here to unpick, so strap in. The first thing to understand is that test coverage can struggle to take into account multiple Boolean predicates on a single line. This means that if you had a series of conditions in an if statement, for example, that you may not necessarily know which these statement conditions have actually had coverage. Similarly, having coverage of a line of code doesn't mean that this line of code has coverage for all circumstances. Consider a function which parses a string, but expects the string to be of a certain width and format. You could have a single test which provides a single string input and get 100% test coverage for that line of code. But you may not have actually tested all the other possible input conditions. So having test coverage of a function can be misleading in that regard. This is why we often want multiple tests to cover the same lines of code. We can use our tests to check that the function handles different scenarios well. If we're just guided by increasing test coverage, we might write one test case for a line of code and think we were done. To put this all another way, the lack of test coverage for a line of code is normally always bad, but having test coverage for that line of code isn't necessarily good either. Fundamentally, test coverage is a metric which naturally brings to mind the old adage of you get what you measure. There is a real danger that we end up just focusing on increasing test coverage. And this leads us in turn to just focusing on types of tests that might give us a better test coverage, but doesn't actually give us fast feedback or confidence that the system actually works properly. What do I mean by that? Well, what kind of test would increase test coverage most quickly? Well, these would be tests that cover a large scope of the production code, such as end-to-end tests. When you have a test that executes the program end-to-end, by definition, a large portion of that program is going to be executed by that test. So on the face of it, adding lots of end-to-end tests will quickly make your test coverage increase. So if your goal was increased test coverage, you might just have lots of end-to-end tests. There's a number of issues with this though. Firstly, end-to-end tests are typically slower to run than faster, smaller scope tests. In addition, when a large scope test failed, we have to accept that any part of the code which was executed could have caused that failure. Another way of saying this is that larger scope tests have poorer isolation. When a test fails, it's harder to isolate which bit of the production code actually broke. This means our feedback suffers in two ways. The tests take longer to run, and when they fail, they take longer to fix. There's another issue with test coverage, which I first encountered on a client's banking system many years ago. When I arrived, the client proudly proclaimed that they had 100% test coverage. I ran the test suite and confirmed that they were indeed correct. And then I looked at the test suite. The tests had no assertions in them. None. Literally all the test suite did was launch the main method of the program and make sure that no exception was thrown. No input was provided to the program, no logic was checked, no program output was confirmed, but 100% test coverage. Now, this is admittedly an extreme example, although unfortunately it was real world. At least I've only experienced this particular extreme once. But it is a reminder that test coverage can check whether or not a line of production code has been executed by a test, but it cannot check whether or not that was a good test of the functionality in question. Focusing too much on test coverage can cause you to reduce this all to a box-ticking exercise where the goal is to game the system to get that 100% number. What you should really be focusing on is writing good tests that provide fast feedback and which also give you confidence that the system works. So is test coverage useless? Not entirely. Firstly, no test coverage is likely bad. Secondly, test coverage can be a really useful indicator of general trends. If I see, for example, the test coverage decrease in a code base, this is at least a sign for me to dig into what's actually happening. Might need to go and talk to the team, look for other signals to help me understand what might be going on. For example, if the team was removing some expensive end-to-end tests to speed up developer feedback, then some decline in test coverage might be totally okay, especially if there's no increase in the amount of bugs that the end user starts seeing. On the other hand, if the test coverage is going down because the developers are commenting out tests rather than fixing them when they break, then that definitely needs to be looked at. To avoid some of the issues associated with test coverage being easily gained, you could also consider only tracking test coverage for smaller scoped unit tests. These are the types of tests that cover perhaps just a few lines of production code at a time. This helps you make sure that you're focusing on providing a generally good degree of coverage with fast, well-isolated tests. For those of you familiar with Mike Cohn's test pyramid, the tests I'm talking about here are at the bottom of that pyramid. Before I wrap up, there are two kind of interesting associated ideas that I wanted to mention. The first is a concept called mutation testing. With mutation testing, the production code gets changed and then you run the tests and confirm that the tests break. This is a clever way to see if your tests are actually doing a good job. If you invert, for example, an if condition in the production code and no tests fail, despite there being test coverage, then that's a sign there's a problem with your testing. Mutation testing is actually quite an old idea. It's originally proposed by Richard Lipton back in 1971, although I first learned about it from a colleague called Ivan Moore, who had in the early 2000s, who had created a tool called Jester. The problem with mutation testing is that it's computationally expensive to run on large code bases. As a result, I've not seen it used in any production system that I've worked on. Another type of testing, which may be easier to implement, is property testing. This can be useful in situations where you want to make sure that different corner cases are being properly handled. Rather than specifically writing a set of test cases with a variety of different inputs for a function, for example, a short string, a long string, a string with white spaces, different formatting, with property-based testing, you can auto-generate multiple different inputs for a single function based on the types of the function parameters. It's a bit of a niche concept outside of functional programming, but it's definitely worth exploring, especially if you're using a strongly typed programming language. So to summarize, a line of code being covered by a test doesn't mean that we have fully tested that line of code. Focusing on increasing test coverage can drive you towards longer running, large scope tests that can really slow down feedback and which still may not give you enough confidence that your program actually works. If you're going to make use of test coverage, pay attention more to the trend over time rather than a particular target, but make sure you also track other metrics like the speed of build, regressions, and new bugs found in your QA or production environments as well to make sure that you've got the right mix of tests. I'd also recommend only tracking test coverage for your smaller scoped, fast unit tests. Now, I hope this was useful. Please leave a comment below. We do read all the feedback that we get. Make sure to like the video if you enjoyed it and subscribe if you'd like to hear more from me or any of the other awesome presenters on the Modern Software Engineering channel. And finally, wherever you are in the world, I hope you are happy, healthy, and safe. Goodbye.